so the sun emits a continuous electromagnetic spectrum with a peak wavelength of approximately 500 nanometers. Based on this wavelength, estimate the surface of the temperature of the sun. So this is actually something that astronomers use. They will look at the peak wavelength emitted by a star, and by looking at the color of the star, you can tell the temperature of the star. All right? So when it says the sun emits a continuous spectrum, that means it emits wavelengths of all different types. Okay, all different wavelengths. What we are talking about is the peak. What is that peak wavelength? Okay, and in this case, that peak wavelength is 500 nanometers, which, funnily enough, is about yellow light. Which, when you look at the sun, don't look at the sun, but when you do, you see yellow light. Okay, so let's have a look. Based on this wavelength, estimate the surface. Estimate the surface of the temperature. Estimate the surface temperature. So, remember Wiens Law? Wavelength max multiplied by the temperature is equal to 2.898 times 10 to the negative 3. We know the wavelength, we're looking for the temperature. So therefore, the temperature in Kelvin is going to be 2.898 times 10 to the negative 3 divided by our wavelength. Now, our wavelength is 500 nanometers, which is going to be, remember we need to put this into meters. 500 times 10 to the negative 9. All right, so if we put this in, we should get a rough approximation of the temperature of the sun. So, 2.898 times 3 divided by oops. And I get 5,796 Kelvin. Now, interestingly, if you look up on Google the surface temperature of the sun, it is about 6,000 Kelvin. So our approximation is pretty good. Considering this is for a black body, it's pretty good. All right, so the equation is not difficult. All right, again, it's just multiplying two numbers to get a constant. So whichever one you want to find, just divide the constant by the other one. All right, any questions? Okay, try the next one, please.